Physics has a super long history of unification. It used to be that we knew all kinds of random things about nature, but we didn't know how they fit together. Just to give you an example, we knew about charge, we knew about magnetism, we knew about light, we knew about chemical bonds, but we didn't know that all of these things were related to each other in some way. And now we have a pretty good idea about how they're related. And we've been unifying our understanding of different parts of nature for hundreds of years now. And where we're at now is we have these sort of nodes of unification. So everything isn't unified with everything else, not quite. But we have a node where everything is pretty much unified, like Newtonian physics, and we have another node like relativity, where everything's pretty well unified, and we also have quantum mechanics, where everything seems to be unified, more or less. But the different nodes seem to be incompatible with each other. It's difficult for us to merge everything together into one theory. Now, physicists say, okay, here's an equation, this is the theory of everything. No, that's not true. It's not unified. And the reason why it's not unified is because each node uses different conceptual axioms in order to build up from. So for example, in relativity, we talk a lot about space-time. Well, we don't talk a lot about space-time in quantum physics or Newtonian physics. It's just not a concept that anything is built on, but somehow that concept is fundamental to relativity. So it's a problem because we define time differently in quantum mechanics and also in Newtonian physics. And energy is also different too. And also, there's a bunch of other things that are different. These are axioms that are fundamental. In mathematics, everything is built on axioms and everything is proven to work. And these are the mathematicians that are doing all these proofs. But the axioms are fundamental, and if you change the axioms, then math breaks. And it's the same thing with conceptual models as well. We have a whole bunch of concepts that we recycle, we reuse, and that's what our model is made out of. But if something goes wrong, like say for example, we've got two different models and they're using different axioms, different concepts are defined differently in the different models, then this is a huge problem, and the models ultimately won't jive very well at some point. And this is the problem that we have today.